Hello everyone, I'm Rex Sham from Insight Robotics. I'm the Chief Science Officer and the founder of Insight Robotics. So we are a company which focuses on forestry, the world's largest carbon sink. So our slogan is saving the world bit by bit, grid by grid. So we are a Hong Kong startup. We have 75 full-time staff now, and we started with 3 founders 5 years ago. So our offices are distributed in Hong Kong, Guangzhou, Beijing, Kuala Lumpur, Jakarta, and Minneapolis now. So what problem that we are resolving is that forestry problems. So wildfire, pests, and disease are the most devastating issues in forestry industry. So the carbon emission coming from wildfire and waste of natural resources caused by pests and disease is causing us a lot of cost in ecological and economical. So like this forest fire in Canada, it just costed $9 billion loss in one single fire. And backward disease, malnutrition of all kinds of plants is causing us a lot of money. So in this picture, you can see that there are quite a lot of hotspots in this satellite scan of the Earth. So all these hotspots right here represents a fire that is bigger than 900 meters square. So it is just a 7 days accumulated data. And each year we have 100 million hectares of land being burnt by forest fires. And also we have 800 million hectares of land of agricultural land or forestry land being damaged by pests and disease. So when we look at the figures, the numbers, we can see that the cause of wildfire is mostly by human. 92% is caused by human, and only 8% is caused by lightning or volcanic activities or sort of like that. So if we look at the carbon emission source, wildfire is actually the single largest carbon emission source that you can imagine. So all the vehicles in the world, it just add up 17% of our carbon emissions. So why the wildfire is always big? It's because we always detect it late. The reason why we detect the fire late is because we rely on smoke on detection of forest fires. So when there's smoke, there must be fire. It's not that simple. So there are haze, smog, air pollution, and smoke all mixed together in the fire season. So like in Malaysia, Canada, China, South Africa, Italy, all over the world, we have the same issue. When there is forest fire, there is usually air pollution. So you cannot distinguish where is the location of the fire and how to fight it. Another problem is that every guard has a problem. Humans are not trained or decided to do boring jobs. So we have a lot of mental fatigue issues in monitoring centers. And you might be waiting for 5 years and there's no smoke or no fires coming up. But when there is a fire, it's late. So more than 50% of the time, satellites are also blinded by the clouds, because we just have satellites surrounding the Earth every 6 hours. So every update of the status of a forestry location requires 6 hours to be provided by the satellite. So the chances that the satellite comes back and see the cloud is more than 50%. So that means that more than 50% of the time, satellites cannot work for early stage detection. So we spent 4 years of scientific research and experiment with the Guangdong Academy of Forestry of China. And then we set up small fire tests, we set up some kind of different big fire tests with them, so as to collect the fire signature when the fire starts at a very early stage, caused by human activities. So after that, we work with the firemen and using our system to try to detect the location of the forest fire and then put the firemen into the exact location where the fire is and so that we can have a much better chance of fighting the fire at a very early stage. So we can have a look at the video right here. To see what we have done. So we worked with the Guangdong Academy of Forestry and the Guangdong Forestry Department in 2011. And then we set up a command center in the middle of the forest. There are 600 firemen coming from 23 cities in China playing with us. We have solar power panels, we have a robot prototype that is being pushed on top of a pole 4 kilometers away from the fire scene. And then we wait for the firemen to set fire in the forest. So we also put in sensors to collect the weather information, temperature, humidity, and the infrared radiation signature inside the fire scene. So all these sensors are burnt with the fire, but they give us very valuable information when the fire hits the sensor. So this kind of fire are artificial fires set by the firemen, and then in our robot, it automatically detects all the fire and reports to the frontline firefighting crew so that they can know how to arrange different kinds of firefighting equipment, including the fire engine, helicopters, or some kind of hand tools carried by firemen to fight the fire. So you can see that in different locations we have the fire icon that is located on the digital map. So we can also have a visible light camera and a thermal imaging camera which penetrates the smoke, and we send out helicopters to fight the fire at the later stage. So other than this, we also spend some time in software development. So after we tested that the system can work within a short range, like 4 kilometers, we continue to develop the detection algorithm and the locating algorithm to optimize the range that we can detect. So recently, we can detect fires that are 13 kilometers away, as shown in our real case scenario. So this is the product that we built and what we are selling now. And all these robots locate on top of telecom communication towers, and they scan 360 degrees 24 hours a day. And this is our command center. You can see that the original paper map that is located on this wall is being replaced by digital screen. And when there is a fire happening, our robot automatically detects it and also display the fire, location of the fire on the map. And then we have a live feed coming from the robot. So this is what the firefighting commanders will see. So this is the location of the robot, and it sees there is a fire happening around 4 kilometers away from the fire scene, and the fire is located right here. So it's very intuitive. You do not need to learn how to geolocate the fire. You do not need to calculate the bearings or stuff like that. So we built more command centers like this, like in Guangzhou City, Nanning City, and now we have 41 cities and 17 provinces in China, which are using our robots to detect the location of the fire and then help the firefighting crew to fight fires much more efficiently. So this is an international case. So we installed our robot in Kelowna, BC, Canada, and it detected a fire in the midnight where there is heavy haze. So on the right-hand side, you can see that there is a fire on top of the mountain. But actually, in the daytime, in 9 a.m., you cannot see there is a mountain right here because of the heavy haze. It's air pollution. So at night, we find out that actually the fire does not start right here. It starts on the other side of the mountain. When the lightning strikes here, it spreads bigger and bigger, and then spreads to the other side of the mountain. So we know that where did the fire start and how did the fire spread using our robot's continuous analysis. And this is our Indonesia case, where it is a private plantation. You can see, actually there is a fire right here, but obviously no one can see it. But our robot detects that there is a fire around 5 km away, which is only 2 meters squared in size, and then we detect it and report it. So we have a user interface, which is based on a browser. You just need to type in the browser, the user address, and then log in, and then you can see a visible light image and a thermal image. So in this image, actually you can't see anything in the RGB image, but actually our robot detects a fire right here. So this is what we provide to our forestry commanders. So the other problem that we solve is the pest and disease detection problem. So we have a lot of plantation loss because of pest and disease. So we can have a look at our drone so that you can see what we are doing. So this is our drone. So it flies into the forest. On top of a car, and then it launches automatically. When the car reaches a speed of 50 kilometers per hour, it takes off. And then it flies into the forest, taking pictures, hundreds of thousands of pictures in the forest, and then comes back automatically. There's no remote control requirement. No one will be needed to monitor the status of the drone. It has his own health monitoring system. So if there is any problem that happens, it will open the parachute and land. And this is a normal landing methodology that we use, head down, so that we can protect the cameras, because the cameras are the most expensive part of the drone. And also it can allow the drone to land at pinpoint accuracy at a location. So this is the launching session. You can see that the drone leaves the catapult launcher automatically. So the value of precision forestry is that we can help all the plantation companies and forestry managers to save a lot of money and get more revenue. So this one is nutrition efficiency. We can increase around $65 per hectare revenue every year by detecting the problems that are happening in the forest. We can tell them there is a missing tree right here, so you can replant it before it reaches the grown-up stage. So there are quite a lot of other cost reduction and revenue increase by using a drone detection. So for the resolution of the images, it is very sharp and clear for inside robotics images. So you can see all the leaves coming from the oil palm, where this is actually the same picture coming from a French competitor, which is the largest agricultural drone manufacturer in the world. For data analytics, we must remember garbage in, garbage out. If your images are not good, then you cannot get good results. So only inside robotics can process the data that is designed for forestry and agriculture. We have a lot of images being transferred into our servers after our drone fly over a certain area. And all this information can turn into insights. Like this one is the photosynthesis activities plot, and this one is the missing tree plot. So you can see the holes right here are the missing trees, and these are the healthiness of the trees. So we help plantation companies to find out where is the pest and disease problem using image analysis, automatic drones, And all this information can be viewed using our software called the Insight Book just online, just like the user interface for detection of forest fire. And we hope that this product or this methodology can increase the public awareness of protecting our world by using technology and helping our world to become a better place to live. Thank you very much.